The paper describes the results of a study of the variability in the distribution of particulate organic carbon (POC) concentrations in the northwestern part of the Black Sea. Coastal ecosystems are among the most productive on Earth. They provide essential ecosystem services such as coastal protection from storms and fish feeding grounds. They are also known to provide another essential service, the sequestration and preservation of blue carbon from the atmosphere and oceans, and are therefore an important part of solving the problem of global climate change. The dynamics of the particulate organic carbon pool in the ocean is central to the marine carbon cycle. POC is the link between surface primary production, the deep ocean, and sediments. It is known that the rate of POC decomposition in the dark ocean can influence atmospheric carbon concentrations. The European Commission has developed criteria and indicators for assessing the sustainability of the blue economy. The components of sustainability measurements in the storage of carbon sequestration subsector are carbon dynamics, carbon valuation, climate change. The research process was based on the following stages: formation of POC databases, build of POC spatial distribution maps, analysis of the variability of the spatial distribution of POCs by season between 2000 and 2023 in their overall distribution over the entire period, and identifying trends. The initial information for the research was satellite data of particulate organic carbon in the period from 2000 to 2023. The data were measured by NASA's Terra MODIS satellite. Processing of raw data was carried out using MATLAB software. Verification of POC satellite data processing was performed using specialized NASA software series data analysis system. Maps of the spatial distribution of POC in the northwestern part of the Black Sea were built using Ocean Data View software. The ODV software is designed for interactive exploration and graphical display of oceanographic profiles, trajectories, or time series data. The statistical characteristic beta POC characterizing the variability of POC concentration per year was calculated using a well-known equation on the slide. Identification of trends in POC variability was carried out on the basis of graphical material built using averaged satellite data in the period 2000-2023. Studies of POC variability have been concentrated in the northwestern part of the Black Sea. After all, it is known that in this part of the Black Sea, there are ecosystems that with a high probability contain the carbon. This is the world's largest colony of red algae, the Zernos, the Lophora field. There are also 7 wetlands of international importance along the coast. The findings are follows. The first, formation of POC concentration databases for conducting research in the northwestern part of the Black Sea. Satellite observation data from 2000 to 2023 were used to build maps of the spatial distribution of POC concentration by season and in general for the entire period. The number of average data for the studied period was about 9,500 measurements for the seasonal distribution of POC. Analysis, their second, analysis of the variability of the spatial distribution of POC concentration in the northwestern part of the Black Sea. Maps of POC distribution in different seasons were built to analyze the variability of the spatial distribution of POC concentrations in the northwestern part of the Black Sea. Average POC data for the period 2000-2023, which were formed into the appropriate database, served as initial data for building maps. Build maps are shown in Figure 1. In Figure 1a, for example, the maximum concentration of POC is observed along the coast from the Yegorlitska Bay to the Kiliski mouth, as well as in the area of the Jarligatska Bay. From these areas with the maximum concentration of POC, its decrease spreads to the south of the northwestern part of the Black Sea. To visualize the general spatial distribution of POC concentration in the northwestern part of the Black Sea, a corresponding map was built, Figure 2. Figure 2 shows that the maximum concentration of POC extends behind the cyclonic movement along the coast from the Yegorlitska Bay and the Andriivska Bay and the Danube Delta, as well as in the water area of the Karkinitska and Jarligatska Bays. The third, identification of POC concentration distribution trends in the northwestern part of the Black Sea. To analyze the intra-annual distribution of POC concentration in the northwestern part of the Black Sea, the corresponding graph was built, Figure 3. The initial data were satellite data of POC concentrations averaged for each month in the period 2000-2023. For Figure 3, it can be seen that the maximum concentration of POC is observed in December-January and is about 647 milligrams per cubic meter. To identify trends in the distribution of POC concentration in the northwestern part of the Black Sea, the graph of its interannual variability was built, Figure 4. Satellite data of POC concentration averaged for each year in the period 2000-2022 served as initial data. Those conclusions are the follows. Based on the obtained calculation results, it can be asserted that the variability of the concentration of POC in the northwestern part of the Black Sea has a seasonal character with an annual periodicity with the cyclonic movement of POC along the coast. The maximum concentration of POCs is generally concentrated in wetlands of international importance, indicating that they perform much broader ecosystem functions than filtering and purifying water. These wetlands store blue carbon, occupying a certain link in the marine carbon cycle. This confirms the important role of these coastal ecosystems within the transition of the blue economy of the studied area of sustainable development, namely increasing the contribution to solving climate and biodiversity problems in accordance with the Sustainable Development Goals. Insufficient consideration of this role in the relevant decisions, in particular according to the Ramsar Convention of Wetlands, will lead not only to a decrease in biodiversity, but also to a deterioration of the climate within the territory of the northern Black Sea. Considering the fact that a large part of these territories has suffered damage as the result of military operations and or under Russian occupation, the situation is very difficult. The task in the wartime is to preserve the health of the studied ecosystems as much as possible with the involvement of specialists and observers of regional and national as well as international levels. The post-war period will require the recovery of wetlands as well as the development of a national blue carbon strategy within the coastal ecosystems of Ukraine. Thank you for your attention.